All right, so the previous video, review 4.9a, talked about how we balanced in acidic conditions. What I want to go ahead and do here is use that ending point for a balanced reaction in acidic conditions and use that as a starting point for the balancing for basic conditions. And so what we're going to do here is we're just going to erase some of these items here. We know that it's already balanced for that, but I want to get rid of that. And I want to get rid of this. So the goal here is to balance for basic conditions. So one thing here that we'll start with is just make that known. I'll write that up here at the very top. And so we're going to put this in blue here. The goal, so the to-do part, is we want to balance in basic conditions. And what this means for us is that we have to actually take into account a couple of items. The first thing that we need to take into account is now that we've got this balance, we have to start by looking at the the hydrogen ions here. And notice that we've got 4, so for every hydrogen ion, we have to add hydroxide to both sides. And so I'm going to go ahead and add that in red. And so here I'm going to add to the right side first, plus 4 OH minus. And I'm going to do the same thing to the left-hand side over here on the left, and I'm going to add plus 4 OH minus as well. Now the next thing for us to do is to actually go in here and take care of any waters that might have been formed. So we look to the right-hand side. Notice on the left-hand side here we've got hydroxide, but the water is already here. But if we look at the right-hand side, notice here we've got 4 hydrogen ions and 4 hydroxide ions. Whenever we have these present, this particular section here is actually going to form water. And when we get hydrogen ions with hydroxide ions, we're going to get here a total of 4 H2Os produced. And that's what's going to be the product here, or the result of that hydrogen ion and hydroxide ion being formed there. So when we actually add that hydroxide ion, that's what's going to result. Let's go ahead and clean up the reaction here and put everything down below and see where we end up. And then we're going to have to get to the point now where we're going to have to cancel like terms. So let's go ahead and add this part over to it. So I'm going to go ahead and circle all of the other reaction, and then we should have that. And then in here, we're going to go ahead and put plus sign right there. And let's look at like terms. So hydroxide only exists on the left-hand side, not on the right, so we'll leave that alone. Same thing for the lead oxide. It only exists on the left-hand side. The water exists here, but notice now water exists on the right, so now we have to simplify here. So we've got 2 on the left, 4 on the right. So what we'll do here is we're going to go ahead and subtract the 2. That will allow me to cancel that side out, and we'll do the same thing to the other side. And then that will give me a total of 2 waters, and then everything else is still the same. So let's go ahead and add all those items back into the mix. And so in order for us to do that, let's go ahead and go from the right side here. It's a lot easier for me, but you obviously want to write this all the way out for 5p, and this is going to be produced from here from 2 I2s, and then we're going to have 5 PbO2s, and then at the very end we're going to have the 4 hydroxides as well. So double check everything. So at this point here, we can definitely say that this was definitely a step. So let's go and separate that out. And so all that's left to do now is to make sure we have the right number of atoms all the way across. So here we've got 4 times 1, that's 4 oxygens, plus these, that's 2 times 5, that's 10. That's 14 total oxygens on the left-hand side. On the right-hand side, we've got 4 times 3 is 12. 2 times 1 is 2, so that's 14. So the oxygens are good. 4 times 1 is 4 hydrogens on the left. And then over here, we've got 2 times 2 is 4 hydrogens, so the oxygens are good. 5 leads, 5 leads. We've already did the oxygens. Here we've got 4 iodines, and we've got 4 iodines here. So the reaction is balanced, and here we're going to go ahead and separate this or box it in purple, bluish color. And so here we can now say that this is balanced in basic conditions. And so that's one of the main differences between balancing in acidic and balancing in basic is these couple of steps here at the very end. We have to make sure that we add hydroxide to both sides for every hydrogen ion. And then once we do that, we make sure we add up the hydroxide hydrogen ion to form water, and then we cancel the water. So those are two additional steps that you'll need to do once you've balanced out a redox in acid conditions. So with that, continue your studying. We'll see you in class.